First of all, I want to just talk about what Spexi does. So Spexi's expertise is really in drones and GIS and geospatial data. And our mission really is empowering humanity to make better decisions about our changing planet. That's really what we're using the DePIN model for. And what we're optimizing in terms of how we build our DePIN in terms of product market fit is centered around this sort of concept. So main points today: problem we're solving, how we're solving it. I want to give you an overview of our protocol and the approach we're taking, and then those network milestones. So problem we're solving. For those who know about our project, you've probably seen this slide almost too many times, but those that haven't, the traditional GIS ecosystem is serviced by fixed-wing airplanes and satellites. And data is very coarse from satellites, and though relatively frequently captured, it's coarse and low resolution. So just as an example from a Google Maps satellite picture, when you zoom in, this is the level of fidelity you get, the actual resolution and the pixels per inch that you get. Fixed-wing airplanes, also another way to do this. Great because they're below the clouds, but they're still super expensive and carbon emitting as well to produce this kind of data. So costly, long delays to get data back. Coverage is inflexible, limited resolution. So again, here's a building in Ottawa on one side and our Spexi network data on the other side, just to give you an example of how much better this data is. How are we solving these problems, and why are we using DePIN? Well, DePIN and the blockchain model, the block model, reward model, really allows us to create the first network for ultra high resolution and standardized imagery at scale. So I mentioned we're experts in drones. We've been actually doing autonomous drone flight for a number of years in our lifetime as a company before we adopted a DePIN model. And I kind of thread that together as we kind of go here, but there's a latent supply of drones out there. A lot of people, even people I spoke to today, that have drones that are pretty much just collecting dust, maybe taking pictures every now and then. So there's a huge supply of drones that are capable to produce this kind of data, and millions of pilots that are out there also willing and looking for something to do with their drone. And if the incentive is correct, as we've demonstrated with the network so far, get really excited about flying and covering whole areas. So on the demand side, there are corporate networks that are buying this kind of data. There's integrators. There's a whole GIS ecosystem. Esri products, ArcGIS, for those who know those things, plug into a wide ecosystem. And then there are a lot of AI use cases, computer vision, metaverse, and others that are buying this data from us today. So how does this work? We basically decided to break the entire Earth up into small zones, and we use the H3 library from Uber to do this, which, I'm sure a million DePINs have been using that library in different ways, mostly to report usage and coverage. But we actually use it as a means to create an index of the globe and allow others to contribute into that map. Each one of these things has parameters for missions to fly. A drone pilot, you can see that's actually a screenshot from the mobile application. A pilot just goes and hits fly effectively. And the drone flight is fully autonomous. It's about a 7-minute flight per hex. Drone pilots love doing it. They have a fun time. It's safer than doing it manually, and it's entirely standardized. So in the future, maybe when beyond the visual line of sight regulations change, maybe they'll have drones in a box at their homes. But right now, the drone regulation requires them to actually be watching their drone as they fly. I just want to hit home that how much higher resolution this is, which I've already kind of touched on, but we're also producing this data in a way that is compatible with existing APIs that plug into a GIS ecosystem that already exists. So it's a problem area we don't have to solve. We can already deliver to customers that are looking for that kind of data. It's 1 centimeter accuracy, standardized, and they can be ordered on demand and delivered within minutes to hours after they're tasked. So that is a bunch of Web 2 stuff, probably for most people. Um, there is a protocol behind all this that we're building, and so that's what I'll turn to next as what we're building. But if the Web 2 approach sounded like anything, it's because we really are focused on abstracting the crypto part for people, which is going to really drive product market fit success for us, which is why we're taking that approach. So from a protocol perspective, it kind of breaks down like this. At the core, there's those missions that I mentioned, those little hexes, data storage, data verification, and governance. But when a pilot goes to fly one of these hexes, a soul-bound NFT is generated, which represents their data, a verified data contribution to the network. The intention is to use a token model to incentivize them for that data set. And then on the flip side of that, our data customers, or us on behalf of our data customers, purchase a license NFT to access the data sets themselves. And so there's a spatial temporal basis to the license, because a data set is, LA today or LA tomorrow or LA whenever. People are purchasing these at a specific time and not just a specific location. So those are two dimensions to that. But effectively, that's what crypto rails were building to facilitate this network. And yeah, this one was just another one that highlights those things. I also want to highlight that, there's a verifiability here, there's a transparency, there's community ownership, there's future composability on top of this protocol as well, which makes it really exciting. This constantly refreshing global map of the world that others can sort of build on top of, as well as us. And the other part I want to mention is that it's actually a relatively active effort versus a passive effort. And so we're actually trying to optimize our economic models and our pricing to match that effort. We don't want a situation where a pilot is getting paid 3 cents for 7 minutes of effort spent. So back to the approach of the protocol. One thing that really hits home for us as we're building this is that it needs to be as good for the mass market as the current offerings in Web 2 products. That is how we kind of approach this project. And, we're trying to build a meaningful real world use case for blockchain technology that's applicable today, not 5 years from now when all the pieces line up. Tokenizing a constantly refreshing global, decentralized global map data layer, the data and the community are the most important elements that we're focusing on there. Obviously, we're harnessing the power of block rewards and tuning supply and demand as we uncover that, and optimizing for product market fit on day one of mainnet, which, it means things like, social logins for our pilots, so they don't have to know exactly what it is right up front. They can kind of get started quickly, but also, providing ways that our data customers can actually purchase this without knowing crypto. And where they're sophisticated enough, allowing the rails to exist that they can go directly, but also providing them that access now, because the data is fresh and available and there's no reason not to. And sorry, last point was just open standards, allow competition, and with entrenched players in the space that there's no other. I think that's one of the powers of the Web3 model that allows us to really succeed. So some milestones. We launched a public beta in December, and so we're really growing our network of pilots. We launched as well a viewer application, sort of demonstrate the value of the data, and cities are really utilizing this application already to consume data. It's kind of neat to think of a decentralized aerial street view of sorts is what that application is. And I'll highlight some stats here. Our top pilot, for example, in testnet has flown 5,089 flights. And right now we're actually paying in fiat, and that ranges from around $8 to $10 in per flight that individual earned, and almost 600 hours of flight time. So that's pretty awesome. And we already have data customers in testnet. So this is some stats which are a little bit old, but they come from the end of the year and comparing the last couple of years of the project. 55 times cities imaged, there's 166. Almost 6,300 and odd missions flown, equivalent on-chain transactions and testnet and all those flight receipt NFTs that we were talking about earlier. Waitlisted pilots and customers onboarded 27. We've had a huge amount of growth in the last year on the network. And this year, we're rapidly expanding into North America. And so recently, we covered Denver, actually. If you go to explorer.spexi.com, that's our Explorer. You can see all the map that's available. You can also see areas maybe near you where you live at home that are up for grabs right now. But these are just a few of the cities that we've captured just very recently, and many more in 2025. This stat, which is up to date from the last December one, is we've now had closer to 80,000 flights, which represents 1.8 million acres imaged, which is a huge number, and 9,000 hours of flight time over that, and growing every minute here. It's a huge amount of effort that the network has produced, and the community is doing an awesome job. I mentioned earlier that Spexi World Viewer. So this is a screenshot of that aerial street view of sorts. This data in particular, we're getting, I mentioned, a lot of traction with cities. Here is a capture of Los Angeles just last week, just outside Los Angeles, of the area that was devastated by the fires. You can see that this data is extremely valuable in that sort of intelligence and insight on the ground conditions. And so I just want to highlight a few use cases that we've had early traction in. Emergency preparedness is a huge one. Disaster response, 911 situational awareness, infrastructure monitoring and inspection, bylaw enforcement, and urban planning and land usage are huge ones for us right now. And I can just quickly go through these because they're more of an explainer of what those are, but there's different use cases for this data, and he highlights here a few more data sets that you can kind of see. Rail, road inspection. And the other really exciting part that we're working on is we're working with a number of companies who are more sophisticated. So, I think there's a vertical for us that is governments and GIS consumers that want to buy this data today and integrate it into their systems and use it alongside analytics that they already kind of possess. But then there are more sophisticated groups that are also trying to access raw data and do interesting things like Gaussian splatting with it, traditional orthomosaics, and really cool AR, VR use cases as well that are really exciting, and we're really looking forward to those coming to online in the next year or so. As well, a lot of computer vision use cases, a lot of modeling. People want to inspect buildings and things like that. So really, really cool stuff going on. That's pretty much it. We're flying drones with code near your house somewhere, probably. And if you're interested, go to spexi.com. Explorer.spexi.com is where you can see the map getting filled, and download the mobile app. And Pete Szym is my handle if you want to connect with me on most things.